Alright, we have seen how can we use binary searching for finding a particular number and its double are available inside an array or not, right? So let's just quickly write the Java implementation of the same thing and validate it on certain input values. So here, before we go ahead and write the main function logic here, we have previously already implemented the binary searching algorithm, right? So I have simply copied the entire function and I have added it here. And let me just make it a non-static function as well so that we can simply reuse it. I mean, even static function can also be reused, but I just want to make sure it is non-static here in this case. So that is the one modification that I have added from previous implementations that we have done. Now here, let's just write the main logic inside this function. So as part of the first check, what I will do is I want to eliminate null values being passed in the array, basically no array at all passed, or the array having at least not having at least two values. I want to eliminate those cases in the beginning itself. So if at all the array that I am getting is null, or the length of the array, that is array dot length, if it is less than 2, then there is no chance that since the array is null or the array doesn't even have two values, there is no possibility that we can have a number and its double are available at separate indexes. That's the reason why here in this case we will simply return false here itself. Okay, if this is not the case, then what we will do, first we will sort this array in the ascending order, then we will basically go to each and every index and we will search if twice the value is available. So here first let's just sort. To sort the array, I will be using the internal sort function that we will be getting from java.util.arrays, and this we will simply pass the array in. It automatically sorts the array in the ascending order. Now we will simply run a loop I equal to 0, I less than the length of the array, and in each and every step I want to go on to the next index. Once I go here, the value at ith index is available, which is nothing but array of I, and we need twice the value at some other index inside the array. For searching that, since we have sorted the array in the ascending order, we can simply use the binary search function that we have copied here. So here first let's just call this dot binary search. Let's just pass the sorted array and we need to look for twice the value at ith index. Okay, and the binary search function that we have already implemented, this basically searches for that value. If at all that value is available, it will return that particular index. If the value is not available, it will return -1. So here first let's just store the index returned by the binary search in some variable. We can say the index is different from whatever the index that we are at, and it has a double the value that we have passed if the index that we have got from the binary search call is greater than or equal to 0. Along with that, since we need a separate index which has twice the value, we will also check if I is also not equal to the index that we have got. If this is the case, then we basically have a particular value at ith index and it's double at some other index, so we can simply return true here. So return true. This is an important check that you need to do. As part of the problem statement, it is clearly mentioned we need to find the double the value at some other index. That's the reason why this check is very important. Otherwise, if we have value 0 and 0's double is 0 itself, right, and it can only be available at specific index as well, so there is a chance that we can return that index as well. So we need to make sure for handling that scenario we are adding that condition as well. Okay, once we search all the values inside the array and we could not find a particular value and it's double, in the end here we will simply be returning false. Okay, so that is the simplest implementation of finding a particular value and its double are available inside the array using binary searching technique. Okay, so here let's just call this function and validate the results. So the array of values that I have passed are 1, 5, 2, 0. If you see here, twice the amount is nothing but 2, right? So basically we have the pair. So if I run this program, the expected output is true. See, that is what we have got on the console. Let me just expand it. And this time I also want to make sure this 2 I'm updating it to 3. So there is no value and it's twice available inside the array. So if I run this now, output should be false. That is what we have got as well. Here instead of this 0, I want to make it 10. So 5 and 10 are such pair. So if I run this program, true is what we should get. True is what we have got. Okay, let's just the scenario where we have 0. So if I pass 0, 0's twice the value is 0 itself, but we need it twice at some other index. But here we have 0 only once. So if I run this program, false is what we are expecting. Because 5 and 10 are there, we have got such result true. If I modify it to 6, 3's twice is 6, and let me just modify it to, instead of 6, let me just make it to 7. So right now there are no pairs. So ideally false is what we have got. Okay, instead of 10, let's just say we have added 0 here. 0's twice is 0 and it is available at some other index as well. So if I run this program, output should be true. That is what we have got. So it is basically working for all the scenarios. Okay, so that's how we find the particular value in its doubler available inside the array or not using binary searching technique. This problem can also be solved using maps as well. If at all, if you want to check out the brute force or the hash map related solution, you can go on to codingpal.org using the problem link in the description and you can find out the same there as well. Anyway, that's it for this one. I'll see you in the next problem.